So I want to make a quick video of my X8 setup with APM. Out front here you can see I've got the 3D Robotics pitot tube, a GoPro Hero 3, the black edition, and a Lawmate 1.2 gigahertz 1000 milliwatt video transmitter. Out the back I've got the two antennas for data telemetry. These are connected to an RFD 900 data telemetry radio. And then my prop is a 13/8 folding carbon fiber prop. And I just made a little prop stopper here out of Tupperware, so it prevents those prop blades from collapsing too much that they don't expand back out nicely when you apply throttle in the air after a glide. The video transmitter, I'm still playing with the video transmitter placement to find its optimal position in regards to radio interference to the other systems. So right now that's loose. Here's the APM. The RFD 900 is velcroed into the back. My speed control is a 65 amp Turnigy programmable speed control. Seems like a nice thing. It was 20 or 30 bucks, which is pretty reasonable. I think most speed controls come default from the factory without the brake applied, so you'll want to program the brake in there so that the prop doesn't windmill in the air. If it's windmilling, it's completely defeating the purpose of having a folding prop for the aerodynamic glide. I'm using the Dragon Link UHF system for man-in-the-loop RC control. I'm using PPM. So I'm getting PPM out of my Dragon Link. This is an older firmware Dragon Link that gets the PPM out of channel 9. The newer Dragon Link receivers all come out as channel 12. So it goes into input 1 on the APM, and then you jumper pins 2 and 3 to use PPM. This is my power for the APM. My whole, the electronic side of everything is powered by a 1000 milliamp 3S battery. I'm using a low noise, and then out of that 3S it's a Y, so one lead goes to the 5 amp UBEC, and then, or 7.5 amp 5 volt output UBEC, and then the other lead of the 3S battery goes straight to my Lawmate video transmitter. Keep in mind the 1000 milliwatt Lawmate video transmitters, they take 12 volts directly, whereas some of the lower milliwatt, like 500 and 250, they want a regulated 5 volts, so be careful. Out of UART 0 on the APM, I'm getting the Mavlink telemetry data, and that's going out to the RFD 900. And then it's wide off to a Minim OSD. So I have both ground station and OSD. And here's my Minim OSD. Video comes out of the GoPro and then goes into one side of the Minim OSD. Telemetry data goes in, and then one video stream comes out to my video transmitter. And then that gives me here. This is a 37-inch Westinghouse LCD. It was the only analog monitor I had in the house. I thought it was kind of ridiculous to have a big screen TV, but then I started taking it to the field, and it was pretty awesome to have OSD on a big screen. So you can download the Minim OSD config tool, update its firmware, and then control everything that you have on your display. Then, of course, I'm using Michael Oborn's Mission Planner application. So the Mavlink data is coming out the one RFD 900 radio, and then coming in the other one that's just attached USB to my laptop, and then that gives me full ground station control here. I'm using a voltage divider that's from Ardupilot. I think it's the 90 amp version. Let's see. Yeah, Ardupilot 90 amp. There's a link to that thing on the 3DR wiki, and I think on the Google code Ardupilot repository. This input voltage, it says to take the input voltage directly from the power source of the APM and then subtract 0.3 of a volt. I found that to be kind of odd for me. I don't know whether there's a error in there or just what, but I played with this input voltage value up and down in order to get the output voltage of the sensor in the mission planner to match what my multimeter said the power was. And what I found is over a few flights that gives me a great, an accurate indicator of voltage, current draw, and then of course that equates out to consumption used. If you haven't donated to Michael Osborne for making this thing, you should, because it's probably the best ground station control software I've ever seen. And of course it's open source. It's done in C#, so if you have Visual Studio on your machine, really easy to download it. His code is well documented to see what he's done. So that's my setup. Hope that's helpful to anybody who's building an X8 or any FPV platform using Ardupilot. And I'm Oso M on RC Groups, and then David Mara on Git. So feel free to reach out if there's any other questions or any help I can give anybody.